Focusing on Friday.
I know.
It's
Friday.
I have Carol later, Mrs. Sargent. I've kind of already clocked out.
Okay, well, you at least want to write the stuff down, so when it comes Sunday night and you're trying to clock back in and think, what the heck do I have to do? At least write the stuff down. Okay, guys. So, continuing where we left off yesterday, we are ready for example 2. Example 2 is an example of a question with a table. Okay. Table below gives a velocity in feet per second of a particle moving along a horizontal axis. The velocity v is twice differentiable function of time t. Okay. At t equals 0, determine whether the particle is moving to the right or to the left. Explain how you know. What are your thoughts here?
Yes.
It's not a yes or no question. Give me a better answer.
Left.
Because why?
-4.
Okay. What is the velocity at 0? The velocity at 0 is -4. And a negative velocity will move the particle left, down, depending on which, what we're doing. So, particle is moving left. And my reasoning is because velocity at 0 is less than 0, aka negative. And in my notes, I have at a rate of 4 feet per second. It didn't really ask that, though. We just needed to know right or left. Okay, B. Is there any time during the interval, 0 to 15 seconds, when the particle is at rest? When is the particle at rest? When velocity is 0. Okay. Is velocity 0 ever? Not that we're officially shown in our list of numbers. Okay. But since it goes from negative to positive, now, there is I don't want to say catch, a restriction. We have to be true, okay? We're not, as Peyton said, we're not shown a 0, are we? However, we want to assume that there's a 0 between -1 and 1. In order to assume that that 0 is there, what do we have to key in on? This function has to be continuous. Is this function continuous?
Isn't velocity continuous? Is that one of the exceptions, like one of the examples you were given? I feel like
Not my brain.
thinking wrong.
There's nothing that says velocity has to be continuous. I mean, I get what you're saying, but mathematically, what makes this function continuous? Yeah. Do you remember, guys, that? If a function is differentiable, it is continuous, right? Now, if it's continuous, it may or may not be differentiable. But if it's differentiable, it is continuous. So, one thing I'm going to say here, because you need to mention this, v of t is differentiable. So, v of t is continuous. That would be the whole reason that we told it was a differentiable function. Okay. And then the key to point out is that at v of 2, it was -1. And at v of 3, it was +1. Or in other words, at v of 2, it was negative. It was less than 0. And at v of 3, it was positive or greater than 0. What theorem says this? Do you remember?
Is it the squeeze theorem?
No. The squeeze theorem just says if it's between two functions.
Oh.
This one is specifically if it's continuous and there's a value in between them, it has to connect. Remember intermediate value theorem, IVT? Okay. The IVT says there exists a time between 2 and 3 where the particle is at rest. Okay, so intermediate value theorem says there exists a time between 2 and 3, so 2 less than t less than 3, where velocity equals 0 and particle is at rest. All these theorems and information keep circling back, don't they? So yeah, basically it just says that if you have, because we know it's continuous, and this value is at -1, this value is at 1, every value between -1 and 1 will be hit because it's continuous. So those points will be connected. So thus 0 will be connected. Okay. C. Use the data from the table to find an approximation for the derivative of velocity at 8. Explain the meaning of v prime of 8 in terms of the particle motion. Show the computations that lead to your answer and indicate the units of measure. So, how do we find v prime of 8 here? What do we have to use? Where does 8 fall? Between 7 and 10, yes? We don't have specific information about 8, but v falls on the interval from 7 to 10. So we can find our average velocity that way. So we can find v prime of 8. You guys remember what we're doing here? Kind of like slope. V of 10 minus v of 7 over 10 minus 7. You guys can look up at the chart. I have my notes in front of me because my chart is on a different screen. V of 10 is 5 minus v of 7 is 3 over 10 minus 7. So 2/3? What's my unit for that 2/3? Okay, it's derivative of velocity. So it's feet per second, or yes, I prefer feet per second squared. Because this derivative is positive, what does it tell me about velocity? Positive derivative is going to tell me that at that point it is increasing. So velocity is increasing. At t equals 8 seconds. Okay. D. Find the average acceleration of the particle for 10 to 12 seconds. Explain what this number means in terms of the particle's velocity on the interval. Well, average acceleration. We're given velocity values here for 10 and 12, right? We're asked to find what? Average acceleration. So acceleration is the derivative of velocity, right? So we can essentially do what we just did. On screen. So in order to find our average acceleration on the interval 10 to 12, v of 12 minus v of 10 over 12 minus 10. And if you go back, I was going to say, isn't it on here? No, it's not. This is the one that wasn't on there. Okay. So v of 12 is 3 minus v of 10 is 5 over 12 minus 10. Negative 2 over 2, which is negative 1. Negative 1 what? Feet per second squared again, right? Because think about it, if you're dividing velocity, which is feet per second, right? Divided by time, which is seconds. So feet per second squared again. And explain what this means in terms of the particle's velocity on the interval. What is the velocity doing? Negative velocity says we will be, well, a negative on the average acceleration says what about the velocity? I think I said that wrong. Decreasing. Okay. So velocity is decreasing on average at a rate of 1 foot per second squared. So velocity is decreasing on average at a rate of 1 foot per second squared, or per second per second. Okay. And E. Let A of t equals V prime of t. Is there a time t equals c guaranteed such that A of c equals 0 in the interval 0 to 15? Justify your answer, of course. How do I want to ask this? First of all, in order to even be able to talk about is there a time when acceleration equals 0 here, we kind of need to go back to like we did, what was that on part B? Because if we want to know is there a time when acceleration equals 0, what do we need to find to show that? That there's a time when the acceleration was negative and a time when the acceleration is positive. Now, in order for us to be able to say that, though, we also have to be able to state that this graph or this function is continuous. And we already talked about it being continuous, right? So that, again, will have to be stated. Is there a time? And I'm going to give you the hint and tell you we already know this answer. We already have the information to support an answer. How's that? You see it?
What we did see was a positive acceleration and then it was a negative.
Look at parts C and D. C was finding V prime, and it was specifically on the interval from 7 to 10, correct? And then D is finding average acceleration, which is essentially V prime. And that was on the interval from 10 to 12. So to the left of 10, it was positive acceleration. To the right of 10, it was negative acceleration. So is it 0 at some point? At some point it is 0, yes. Okay. So, first of all, we do need to mention the continuous part again. So I'm going to say because v of t is differentiable, then v of t is continuous. And I'm going to show what we found up above, that v of 10 minus v of 7 over 10 minus 7 ended up being what? 2/3. And v of 12 minus v of 10 over 12 minus 10 ended up being -1, I believe. That does not look like a -1. There we go. And we know we can acknowledge that 2/3 is positive, so it's greater than 0. -1 is negative, so it's less than 0. And so I can say, thus, a of t equals 0 on the interval. Now, it just asked about 0 to 15. We can at least narrow it down to 7 to 12, right? So I'm going to say on 7 to 12, 7 less than or equal to t less than or equal to 12. And how do we know this? Because v prime of t changed from positive to negative at some point. Okay. Remember, that is those are average accelerations. We don't know the specific acceleration at each point, which is why we can't say specifically when that acceleration equals 0. Okay. That was our table. Now we've got to do a graph. Then we've got to do some calculator questions. Busy day. Okay, example 3. The graph at right is velocity. Always something I check. Like, I don't know, for whatever reason, my gut says, okay, what is this graph? I have to know. The velocity of an object moving on a line over the time interval 0 to 10, assume that the positive direction is to the right. On what interval of time is the object moving to the right? When does an object move to the right? When what? Okay. When velocity is positive. So, when is velocity positive here? On the interval from 4 to 10. This is a velocity graph, so positive velocity is above the x-axis, right? Okay, so v of t is greater than 0 on, what did we just say? 4 to 10. Okay.
If you were to do it in the other notation, would it be parentheses or bracket.
Parentheses. When we don't have the equal signs, we say parentheses usually. I'm trying to see if there would be a problem with using brackets, and I'm not.
Wait, so why is it here? It's just greater than. It's not greater than or equal to.
Because at 4 and 10, my velocity is not positive,
Okay, got it.
it's 0. And officially, mathematical definition, 0 is neither positive nor negative. So I guess it would have to be parentheses. I just kind of went around in a circle and answered my own question. B, when is the object speeding up? I feel like we talked about the whole speeding up, slowing down thing yesterday. We did. When does something speed up? Same signs, right? So we are looking, wants to know when they speed up. So we're looking for when v of t, so velocity, and acceleration have same signs. So I just kind of wrote my explanation before we answered the question. But, you know, that's what you have to acknowledge there. So, do we have any positive velocity and positive acceleration, or negative velocity and negative acceleration? 4 to 6 is positive and positive. Because from 4 to 6, it's above the x-axis, so velocity is positive. And it's an increasing slope, so acceleration is positive. The flat spots have constant acceleration, so those you can't talk about signs, okay? From 2 to 4, it's negative velocity but positive acceleration. From 8 to 10, it's positive velocity but negative acceleration. So, on 4 to 6, 4 less than t less than 6, since v of t is positive and a of t is positive. I just noticed in my notes I actually said, instead of a of t, I said v prime of t. You know, either way. Okay. See when you're ready. How fast is the object moving at time t equal 3 and in what direction? How fast? What am I asking for? Speed. And how do we do speed? Absolute value of velocity. So we're looking at the absolute value of the velocity of 3. What's the velocity of 3? Oh, yeah. Oh, well, okay, yeah. I was really confused. I'm like, how is he 5? That's at -1. That was my brain. That's why I just paused. I'm like, why 5? Okay, so don't do what I just did. Read the labels, yes. Okay, so it's the absolute value of -5, which is indeed 5. Okay, and what direction? Because it was negative velocity, it is moving left in a negative direction. So moving left, since v of 3 itself was less than 0, or in other words, negative. Okay. D, when you're ready. What is the average velocity over the time intervals 0 to 4 and 4 to 10? Show the computations that lead to your answer. Okay. Thoughts here? In order to do average velocity,
So the area.
we are going to talk about the area thing. Okay. We do average velocity. Officially, I think change in position over change in time, right? But this is a velocity graph. So I don't have position, I don't have the points of position, so to speak. So this is, displacement over elapsed time. But yeah, you have to look at the area. So we need to look at the area from 0 to 4. And we're going to look at the area from 4 to 10. So, okay. Wrong way. From 0 to 4. First of all, this is below the graph, yes? So keep that in mind. But I see a square and a triangle. Is that what you see? My square is 2 by negative 10, which means negative 20. My triangle is 1/2 times 2 times negative 10. Is that making sense? So that's negative 10 for my triangle. Negative 20 plus negative 10 is going to be negative 30. Writing down my information. Going back to the other page now. What about 4 to 10? You can see a trapezoid if your brain likes that. Or if your brain doesn't like that, you see a rectangle and 2 triangles. Although those 2 triangles make a rectangle, don't they? I don't know how you see this. It's whatever geometry your brain likes best. That rectangle in the middle is 2 times 15, which is 30. The triangle is 1/2 times 2 times 15, so half of 30, which is 15. And that triangle's 15. Are my calculations making sense? If you do your calculations a different way, if you get the same answer, you're good to go. So 15 plus 30 plus 15. Which is 60, right? Now, it asked for average velocity, right? What we just found was the distance. Okay, the total distance or the displacement. So if we're doing total distance divided by elapsed time, well, average velocity on the first interval, the total distance is negative 30 divided by what's the elapsed time there? 0 to 4 is 4. And I feel like over here I should have probably put that we're doing total distance divided by time. And negative 30 divided by 4 is, I don't know, negative 7.5. Your other average velocity, the total distance is 60. Divide by an elapsed time. What is 4 to 10? 6. And 60 divided by 6 is 10. I do not have labels on mine. Do we have labels on this graph?
No.
Oh, we don't have labels. That's why I don't have labels on mine. Okay. Thought maybe I just forgot to put them on there, but I'm still back on the other example where we had labels, so. I guess, you know what, I used the I used the word total distance here, and I have to stop and think, yes, maybe I should have used the word displacement. Now, and the reason I said that, because if we talk total distance, we wouldn't necessarily have negatives. Because as I'm looking at the next one, when it says, what is the total distance traveled by the object? Show the computations led to your answer. So total distance, so we looked at two different intervals, didn't we? What is the distance covered on the first interval? So from 0 to 4, it's negative 30, but that's just saying like 30 to the left. And so when we talk about total distance here, we're going to think about the absolute value of the negative 30. And then we also had the interval from 4 to 10. And from 4 to 10, it was 60. So that whole idea of left versus right, this is moving 30 left, this is moving 60 right, but the total distance is you're looking at the positives there. And so 30 plus 60 is, excuse me, 90. And on this one, I actually put 90 units, but 90 would be a fine answer. So remember, total distance is the area under a velocity versus time graph. And I will say I have a note to myself that I went back to page 145, which is a similar area to where we went back to yesterday, wasn't it? I think yesterday we went back to page 144. You know, the whole idea of area being the area under the velocity versus time graph. We talked about that back on page 145. Because I needed to go back and look that up. Okay, F. When is the object slowing down? Well, for it to slow down, what has to be true? Not necessarily. What did I say equals? Velocity and acceleration have to have what? Not same sign. Opposite signs. Remember, if the signs are the same, we're speeding up. If signs are opposite, we're slowing down. So V of t and A of t have opposite signs. Well, didn't we already talk about speeding up? I think we already talked about that, didn't we? Yeah, speeding up was part B. When are we going to have opposite signs here? Two to 4. I have a negative velocity, positive slope, so positive acceleration. And
8 to 10.
8 to 10. Velocity is positive, but has a negative slope. So, on 2 to 4, velocity is less than 0. The acceleration is greater than 0. And from 8 to 10, velocity is greater than 0, and acceleration is less than 0. Those last two questions are easier, in my opinion. G. When is velocity increasing? Okay, so 2 to 4, 4 to 6, or 2 to 6. Technically, they have velocity is increasing when acceleration is positive, right? And they both have positive acceleration. They technically have two different positive accelerations, don't they? So they are not increasing at the same rate. However, they're both increasing. So I think you could say it either way. You could say 2 to 4 and 4 to 6, or you could just say 2 to 6. Okay? So when is the velocity increasing? When acceleration is greater than 0, velocity increases. And that was, what did we just say? 2 to 6? Yeah, 2 to 6. 2 less than t less than 6. And H. Why couldn't they have made this the first question? On what interval does the object move at a constant speed? Constant speed is going to be when what happens? Acceleration is 0. When is acceleration 0? 0 to 2 and 6 to 8. Okay, so acceleration is 0, which means the slope of velocity is 0, right? You could say v prime is 0 if you want. Okay, calculators, let's see. I don't know, if we don't get this whole page done, obviously the homework's still going to be assigned, you know, just a little bit of different stuff. Okay, example 4. First of all, how do I know this is a calculator question?
There's a calculator.
Okay, besides the fact it says calculator question stems, look, no, but I mean, no, that is what I wanted to hear. There's a calculator in the right corner, yes? You have a page in homework that has a calculator beside it. Those are the ones where, on the AP test, they don't technically say, they say a calculator may be required. So it's not that it has to be required, but it is. It could be. Okay, and on several of these, the calculator is required. An object moves along the x-axis from 0 to 6. Velocity is given by this function. A, 4t equals 4. Is the object speeding up or slowing down justified? So what do we have to know if the object is speeding up or slowing down? Acceleration and velocity, right? Because if velocity and acceleration have the same signs, speeding up. If they have opposite signs, slowing down. Now, if you feel the desire, you can do that derivative by hand. I'm not touching that, though. Okay? Because the whole point is we can use the calculator. Okay, and this is a fancy way to use the calculator even. So, I would recommend you type your equation in your Y1 list. Y1, Y2, wherever you have it open. Okay, because we need to find the velocity of 4 and the acceleration of 4. And this is a way that we can what's going on here? Aha, there we go. So, I cheated, I'm ahead. In Y1, I have this equation typed. Natural log of, we're just in terms of x minus 1500 x cubed plus x squared plus 2x, and that quantity is raised to the 4/5. That's, for me, it's in Y1. You put it in whichever Y you have open, okay? And then I'm not going to graph it, because I don't think I need to graph it for part A. Well, oh, wait, that might be quicker.
Yeah.
Well, okay. I guess it depends if you want specific values. How's that? Because, wouldn't be easily able, you'll be able to tell if acceleration is positive, you wouldn't be able to get a value. Officially, do we have to have values though? It doesn't say we have to have values. You can just say positive or negative. And so if I graph y1, I don't know. What does a graph look like? I didn't look at it, to be honest. Okay. And where is 4 about? X equals 4 is about over in that area, yes? So here's a quick and easy route if you don't want the specific values. Okay, this is what type of graph? This is a velocity graph, yes? What do you know about the velocity at 4? It's positive because it's above the x-axis. What do you know about the acceleration? It's negative because the slope is negative, decreasing. Did we just answer the question? Yes. Okay. Now, I will show you what I did earlier. Because I have, and you could get, like I could do a trace here. Whoops, what did I just do? I could type trace. When I type trace and type in the value 4, it will take me to that specific value. So I know that my velocity at 4 is 4.4969. I can't read that next number. Is that 805? Doesn't matter. Acceleration. Could we do that on the graph here? Curious here. Trace. Ooh, we could. Nope. Okay. What I did is on my main screen, if I use the alpha trace button, I can grab y1. Well, okay, this would find velocity. Because if I type in y1 and then just put in 4 after parentheses, I'm substituting 4 into whatever my y1 equation is, which my y1 is the velocity equation, right? So that's that same number I just got on the graph. Now, do you remember how to do a derivative? Math 8 is what I know it as. And if I go to math 8, d dx, I'm not going to have to waste time typing my equation in. And where can I put in there? y1 evaluated at 4. So if you need that specific value, that is the derivative of y1. So the derivative of velocity is acceleration. And so that is negative 2.713104787. All of that to say, velocity at 4 is positive, and acceleration at 4 is negative, and so we were slowing down. Okay. At what time does the particle change directions? This is where you do want the graph. When does my particle change directions? When velocity is 0. Okay. How can I find when my velocity is 0 here? Where does it cross the x-axis? And so we can find our zeros. Remember that? Second, the trace or calc button. Number 2 is 0. So I can move to the left of that one that's 0 point something, left bound, right bound. Yes. One of my zeros is 0.3910965. or about 3.91. And that is where my graph changes from negative to positive. Velocity also equals 0 at the other one, and I will tell you the other one is 5.007. And there, that's when my graph is changing from positive to negative. Okay, so you can do these various things on your calculator, right? Do I have time to talk about 5 or not?
2 minutes.
Let's see, a particle moves along the x-axis so that at any time its velocity is meters per second, given by this new function, v of t. What is the acceleration of the particle at t equals 4? What does this tell you about the direction of the particle? So, acceleration is the derivative of t, yes? Or derivative of v. I don't have to find that by hand, right? I have, probably in my y2, I have that equation typed in. 4 plus 2.3 sine of 0.85 t. I have that typed in. If we want the acceleration, I can do the derivative evaluated at 4. So what I'm going to end up doing here is d dx of v of t evaluated at x equals 4. That really should say v of x, I guess, but, you know, you get the idea. Are you seeing how I would say to do this? So if I go to my regular screen and do Math 8 again, put in dx, this time my equation is in y2, and it was at 4, wasn't it? So negative 1.89. So the acceleration at 4 is negative 1.89 something or other.
Meters per second.
Yes. And because that is negative, the particle is going where? Being pushed left. It's going left, yes? Particle's going left. Okay, guys. We have 2 we didn't get to. I will say, the answer key is online if you do want to look at those in the notes. Okay? Go ahead and do the homework. Okay? For the most part, you should be okay. You might run into a snag here or there. Do the homework. Homework is due Monday. Homework answer key and the notes answer key should both be already online. I think I have them open. Okay?
Left in.
Laughing.
Have a good weekend, Mrs.